Today we're going to begin looking at quadratic functions. So a quadratic function in vertex form is f of x equals a times x minus h quantity squared plus k. In this form, hk is the vertex of the parabola. So notice h has a negative here, so it's opposite of what's inside the parentheses, and then just regular k here, okay? Then is this on the next page? No. Then the axis of symmetry will be just x equals h. Okay? So those are the two things that we can easily find out from vertex form of a quadratic formula or quadratic equation. So the regular form of a quadratic function is ax squared plus bx plus c. And here, that gives us a parabola. If a is positive, then the parabola opens upward, like here. Okay? If a is negative, then it opens downwards. And that's the same with the vertex form also. And here's what we've had written before. The vertex is hk and the axis of symmetry is x equals h. And it is x equals h because it's a vertical line, so it has to say x equals in front of it, not just h. So the first example says graph the quadratic function, identify the vertex, x and y intercepts, and the axis of symmetry. Okay, so this quadratic function is in vertex form, so we can pick out h and k pretty easily. H is 3, remember it's the opposite of what's in the parentheses, and k is exactly what is on the outside, so negative 9. So we can graph that, 3, negative 9, right there is our vertex. Okay? Skip down to the axis of symmetry. That'll just be x equals h, which is 3. So the axis of symmetry is this vertical line here. And that's where the parabola can fold across. Okay, to find x and y intercepts, we're going to do that just like we did with linear functions. So an x-intercept, we let y be 0. So we've got y, which is 0, equals x minus 3 squared minus 9. Be parentheses there. Okay, so add 9 to both sides. Take the square root of both sides. And then we've got two situations here. X minus 3 could be negative 3, or x minus 3 can be positive 3. And so we figure out both of those by adding 3 to each side. And we've got 0 and 6. So the x-intercepts are 0, 0, and 6, 0. And so we can plot those just like that. And then the y-intercept, we let x be 0. So we've got y equals 0 minus 3 squared minus 9. 0 minus 3 is negative 3. Negative 3 squared is 9. And 9 minus 9 is 0. So the y-intercept is just 0, 0, just like one of the x-intercepts. And then we can plot our parabola. And so it'll go up kind of like this. And you can see it opens up. And we can tell that because A is positive. A is 1 here, positive 1. And so there is our parabola. Let's look at one more example of that. So again, the vertex here is HK. H is positive 2, K is negative 1. We can see that since A is negative, then this parabola will open down. The axis of symmetry is x equals 2. So let's plot these two things. Okay. Then the x-intercept, we let y be 0. So we've got 0 equals negative x minus 2 squared minus 1. So add 1 to both sides. Divide both sides by a negative. Take the square root of both sides, which we can't do because we cannot take the square root of negative 1. So that means that there are no real x-intercepts. There might be imaginary ones, but we're not going to mess with that. And then the y-intercept, we let x be 0. So we've got negative 2, and negative 2 squared is 4. We still got that negative on the outside, so that's why we've got a negative 4 there. So we end up with negative 5. And so our y-intercept is 0, negative 5. Okay? Now, because the axis of symmetry makes things symmetric, then we know we can take this 0, negative 5 and stick it over there to help us graph our parabola. And so we have something like this. Okay, what if we have an equation in this form, in the form ax squared plus bx plus c, but we want to get it in vertex form? Well, that's where we're going to complete the square. So we've done this before. So let's look at it again. We've got 2x squared plus 20x plus 42. We'll leave that off. We don't need that. Okay. The first thing we need to do is remember the value in front has to be 1 in order to complete the square. So we're going to divide everything by 2, which luckily that can be done easily here. And then we need a number here. I'll stick that 21 on the outside, where our value in here, where we're adding, we're also subtracting off. Okay? Now, I think I need to rewrite this. So, I need to keep this 2 out here. I wish that we could doing that. We're adding, and actually, we don't even divide the 42. We keep the 42 on the outside. And then we have minus 2 times what we're putting in on the line here. Now, why did I say 2 times? Because there's a 2 out here that we're multiplying by, so we also have to multiply over there to the right. Okay, so what goes in the spot? Remember, we take b squared over 2. Okay, so, it's b over 2 squared. Okay, so that'll be 10 divided by 2 squared. 10 divided by 2 is 5, and 5 squared is 25. So that's what goes in our spaces there. Okay, so then we have a 2 out here. And since we've got the plus 25 on the inside, x squared plus 10x plus 25 is a perfect square trinomial that factors just to be x plus 5 quantity squared. And then out here we've got 42 minus 50, so that gives us -8. And so now we've got our function written in vertex form. And so our vertex must be h, which is -5, and k, which is -8. Okay, let's look at another one, and we're going to complete the square again. Don't worry, in case you didn't catch on there. And then we're going to graph it, just like we did on those last ones. So we've got -x squared minus 2x plus 3. The number in front needs to be a positive one, so we're going to factor out a negative from the first 2 terms. And we'll keep our 3 on the outside. And then, since we're adding in here, then we need to subtract on the outside. But we're subtracting a negative because we have to multiply by that thing in the front. So a -1 times our blank. Okay, so what's the blank? B over 2 squared. Well, -2 divided by 2 is -1, and -1 squared is 1. So in our space goes 1. So we have, when we factor, x plus 1 squared. And then we've got 3 minus -1, which is 3 plus 1, so plus 4. So our function, find somewhere to write this, is -x plus 1 squared plus 4. And we're going to go through the same process as before. The vertex is hk, so that's -1, 4. This one will open down, by the way, because of the -a out front. The x-intercepts, to go back here, let y be 0, so we've got 0 equals -x plus 1 squared plus 4. Take the square root of both sides, and so we have plus or minus 2 equals x plus 1. So x plus 1 could be -2, or x plus 1 could be +2. So subtract 1 from both sides. And so our x-intercepts are -3, 0, and 1, 0. Then the y-intercept, let x be 0. One squared is just 1. And -1 plus 4 is 3. So the y-intercept is 0, 3. So let's graph those two things. Okay. And since we have our axis of symmetry is x equals -1, then we can reflect that over to give us an extra point to graph by. And now we can graph our parabola. It asks us two more questions. It asks us, what is the domain? Well, the domain of a parabola in any case is -infinity to infinity, because it does go x-axis to negative and positive infinity. And the range here is going to start up at 4 and go down. So we're starting with -infinity and going up to 4. And we're including 4, so we need to put that in brackets. Okay, so that's an example of how to take your function, complete the square, find everything, and graph it. Next, we're going to look at using the determinant and what that tells us. Now, what is the determinant, first of all? The determinant is b squared minus 4ac. Now, that might sound familiar. If you think about the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. Well, b squared minus 4ac is called the determinant. And if you'll remember when you use the quadratic formula, if that number under the square root, the determinant, is 0, then we end up with just one x-intercept because there's nothing to plus or minus there. If the number under the square root, the determinant, is positive, then we have two x-intercepts because we say plus or minus there. If the number under the square root, the determinant, is negative, well, there's no real x-intercept because you can't take the square root of a negative number. So this is just pointing out that that number is called the determinant, and we'll use it in example 5. We'll go back to that. So determine the vertex. Oh, I guess we're not using that in example 5. So using the determinant, you can find out if there's one x-intercept, two x-intercepts, or no x-intercept. Okay, what if we have the regular equation, our ax squared plus bx plus c, and we want to find the vertex and all of that, okay? So we use a vertex formula, and for that we say that x is -b over 2a. That tells us our axis of symmetry. Okay, x is -b over 2a. That gives us the x coordinate of the vertex, -b over 2a, which is nice because then you can find the y value of the vertex just by plugging in for x. So let's look at an example here. So the x value of the vertex would be -48, because that's b, over 2 times a. which is -3. So the x value of the vertex is 8. And to find the y value, we just plug in 8 for x. Okay, so we've got -3 times 64 plus, I didn't write this down. I don't know what 48 times 8 is in my head. Sorry about that. So let's find it. It's 384. Minus 165. And so once we put that in the calculator, we find out that the y value of the vertex is 27. So the vertex is 8, 27. So not too difficult. Example 6, we have a word problem. It says, at the end of his career, Sherlock Holmes retired to a small farm in the country and took up a hobby of beekeeping. Being of an analytical mind, he could not just watch a bee fly from flower to flower. He formulated a mathematical model for the parabolic path the bee follows from flower A to flower B. I wonder if he actually really did that. Interesting. The path is given by f of x, where x is the distance in inches along the ground from Sherlock. So Sherlock's here, x is this distance, and we have flower A and flower B. Those look more like suns, but whatever. And we have our function -0.03x squared plus 1.8x minus 24. We're asked, first of all, what is the maximum height the bee reaches as it flies from A to B? So the maximum height is going to be up here. Now what is that in a parabola? That is the vertex. So all we need to do is use this equation to find our vertex. So let's write that down again. We've got f of x is equal to -0.03x squared plus 1.8x minus 24. So to find the x value of the vertex, again, we use -b over 2a. And that gives us 30. To find the y value, we plug in 30 for x. And that gives us 3. So the value of the vertex is 33. Now what did that tell us? We were asked what is the maximum height that the bee reaches. So what is this distance from here, from the ground up to the height? Well, that would be the y value. So the bee reaches 3 inches off the ground. The next question is, how far away from Sherlock are flowers A and B? Okay, if we go back to our picture, so this first distance will give us A, and then the distance from Sherlock to B is here. So what are those 2 points? Well, those are the 2 zeros where we cross the x-axis. So we're finding A0 and B0. So in other words, we need to find the x coordinates. Okay, so that means we need to take and plug in 0 for y, and solve for x. it'll make things a little bit easier here, just to get rid of our decimals, if we multiply everything by 100. You don't have to do that, but it just makes things nicer to look at. And we don't have those decimals sitting in there. And then it would be also nice to get rid of the negative and the -3, so we can factor nice and easy. Can we divide by 3 here? Sure we can. So we'll divide everything by -3, and that'll just make things look better and easier for us to work with. Okay? So now we can factor. What multiplies to give us 800 that adds to be -60? Actually, -20 and -40. So we set both of these equal to 0. And so x is 20 and x is 40. Well, I wonder which is which here. The shorter distance must be 20. The longer distance will then be 40. So we've got our two x-intercepts at 20, 0, and 40, 0. So we can say that the B is first 20 inches away and 40 inches away. Okay? Okay, two more examples. The next one says a farmer has 200 feet of fencing and wants to build 3 adjacent rectangular corrals. Determine the dimensions that should be used to maximize the area and find the area of each individual corral. Okay, so first of all, we've got 20 feet of fencing. Now the fence has to go all the way around. It also has to go through to make 3 separate corrals. Okay? But we know that the area is length times width, right? So area is length times width, or x times y. The perimeter here would be, let's see, there's y and y, so that's 2y. And how many x's? 1, 2, 3, 4. So the perimeter, it's a little more than the perimeter, I suppose, because you got the stuff inside, but we'll still call it P, is 4x plus 2y. Now, if we've got that information, we've got 2 equations, and we can use them to find x and y. So how do we do that? With the perimeter equation, we're going to start by solving for y, because we know that the perimeter is 200. We were told that in the problem. So I'm going to solve this for y and then plug into my area formula. Okay? So we've got 2y equals 200 minus 4x. So y is 100 minus 2x. So I'm going to take my area formula, and we're going to plug a y in of 100 minus 2x. What good is this doing us? Well, we now have a quadratic function, the equation for a quadratic function that can help us find what we need. We want the maximum area, okay? So we're going to be looking for the vertex again. To find the x value of the vertex, we do negative b over 2a. And I know I've got this switched around, but a is still in front of the x squared, so it's negative 2, and b is still in front of the x, so that's 100. And so the x value of the vertex is 25. To find the y value of the vertex, we can do a few different things. Well, we'll do this. We'll find the area where x is 25, and so we plug in 100 times 25 minus 2 times 25 squared, and that gives us 1,250. So our vertex is at 25, 1,250. What have we just found? Okay, well, we found x, but what was x? Okay, x was this distance. Okay, so just one of those distances gives us x there. So this side of our corral is 25. Now 1250 is not y. If we look back, we used the formula where a equals stuff with x in it. Okay, so a is our y value. We just found the area, the maximum area. Okay? Okay, so it says find the dimensions that should be used. Okay, so we just found x. How are we going to find y? Well, we know that our maximum area is now 1250, right? Area equals x times y, and our maximum area is 1250, and we know what x is. That's 25. So that lets us find y. Why do I have 4? Oh, I'm sorry. I used the wrong formula. Okay, we need to go back and use the perimeter formula to find y, okay, because 1250 is not our maximum area. Okay, so what have we just found here? We have found that our x value is 25 and our y value is 1250. So the distance here is 25, and the distance along here is 1,250, and I believe that's in feet. So our maximum area will be given by 25 feet by 1,250 feet. Okay, so it says find the area of each individual corral though. So the area will be 25 times 1250. That'll be all 4 of them together. that is 31,250. So that's the total area of the whole thing. So that means the area of each corral will be this number, the area of the whole thing, divided by 4. So 7,812.5 square feet. And for our last example, find the quadratic function of best fit. So we've got some data here, and we want to find the function that best fits this data. Thought I had something on there. So you're going to use Desmos to do this. Remember, just like with your, and I may create you a video for this, but if I don't, just like with your linear function, when you're finding the linear function of best fit, you're going to create your table, x1, y1, and then when you type in, okay, you're going to say y sub 1 and our little squiggly thing, and then we've got a x sub 1 squared plus b times x sub 1 plus c. And it'll give you what a, b, and c are to work in there. And it ends up being negative 0.034x squared plus 2.793x minus 14.285. Okay, this is the last two examples of section 2.1. Sorry, I had to stop there and do some things. So, example 7, we've got a farmer has 200 feet of fencing and wants to build 3 adjacent rectangular corrals. Determine the dimensions that should be used to maximize the area and find the area of each corral. Okay, so what we've got here is we've got a rectangular area where the width is x and the length is y. Okay, and we know that if we're looking for the area, then we can multiply length times width, right? Well, we don't know the area yet. That's what we're looking for. And we don't know x or y. The only information that we've been given is what we're going to call the perimeter, but it's really not. The perimeter would be this, but we're actually adding in these two dividing sections there. So we've got y and y, so that's 2y, plus we've got 1, 2, 3, 4 x's. And that gives us what, again, we're going to call the perimeter. And the perimeter, we were told they have 200 feet of fencing. So what we're going to do is we're going to solve for, let's see, that should have been for x there. We're going to solve for y. And then use that to plug in here, and that will help us find the area, okay, because we'll just have two unknowns. So to solve this for y, subtract 4x from both sides and divide by 2, okay, and then we've got our y, so we can plug in up here 4y 100 minus 2x. Okay, and then once we multiply through, then that tells us our quadratic function, or the equation for our quadratic function here. Okay. Now we're looking for a maximum area. So a maximum would also be the vertex. Okay, so we're looking for the vertex. How do we find the vertex? Use negative b over 2a. Now I realize that things are switched around here, but a is still in front of the x squared, it's negative 2, and b is still in front of the x, that's 100. So we find that x is 25. Okay, then we want to find a, and remember that a is the area. So we're going to plug in 25 for x. And that gives us an area of 1,250. It says, determine the dimensions that should be used to maximize the area. So the maximum area is going to be 1,250. All of this in here is 1,250 square feet. Okay? So, if that's the case, we've already found that x is 25 feet. Okay? We need to find y. Well, how can we find y? We can plug back in to our perimeter formula. So our perimeter was 200. Well, let's see. Once we've got it solved, we have y equals 100 minus 2x. So let's go ahead and use that. That'll be easier. Y equals 200 minus 2x. So we have 200 minus 2 times our 25. So that's 200 minus 50, or 150. So y, this whole distance from here to here, is 250 feet. Okay, again, determine the dimensions that should be used to maximize the area. So the dimensions are 250 feet by 25 feet. Okay, that's the dimensions for the total corral. Okay, but we've got little individual pieces here. And it says, find the area of each individual piece. Well, we can do that by taking our area, 1250, and dividing by 4. So, to find the area of each corral, then we've got 1250 divided by 4, and that gives us 312.5 square feet. So each corral is 312.5 square feet, and the dimensions for the entire corral are 250 by 25. I wrote something down wrong here, didn't I? That's actually just 150. Otherwise, it's not going to add up. So the dimensions are actually 150 by 25. But that doesn't change the area because we just divided the area by 4. Okay, and then the last example is finding the best quadratic function, the quadratic function of best fit. Okay, so we've got some data here, and so what you're going to do is go over into Desmos and list your data in a table under x1, y sub 1, and then to find your quadratic function, then you'll say y sub 1, little squiggly, a x sub 1 squared plus b x sub 1 plus c. And that'll give you a, b, and c in Desmos. And what you should end up with is negative 0.034x squared plus 2.793x minus 14.285. And that concludes this section.